All right, so now we're going to look at this at consumer optimum. How do consumers make optimal choices, or how do they make the best choice? Right, that's what optimal means. First of all, what is consumer optimum? Well, it's the set of goods and services that maximizes the level of satisfaction for a given consumer, subject to a budget constraint, or in other words, limited income. So, of course, we can't purchase everything that we want because we are limited to a budget. So that's part of the consumer optimum, is the consumers trying to make themselves as well off as possible, but of course they're limited by a budget constraint. They're limited by an income. So that's the idea behind consumer optimum. All right, so here we've got two different products. We've got digital apps and portable power banks. And so we've got different quantities here. And then if we focus on the left half of the table first, looking at digital apps, we can see that we've got total utility is increasing from additional apps. We could calculate the marginal utility of each additional app as the difference between total utility, the change in total utility going from one app to the next. And then this last column is marginal utility per dollar. Okay, so we're told that the price of digital apps is $5. So if we take marginal utility and divide it by the price of apps, 5, we basically get marginal utility per dollar. Now, why is this important? Why do we care about this? This is basically what we call bang for your buck, right? So the bang is the satisfaction, and the buck is, of course, how much you have to spend to get that satisfaction, right? So that's what marginal utility per dollar is telling us. It's telling us how much does the satisfaction cost, or how much can we get per dollar, in other words. So for the first digital app, it provides a marginal utility of 50 utils. And since the app costs $5, it's basically 10 utils per dollar spent. And this is going to be important as we move forward talking about consumer optimum. So keep that in mind. Now let's look at portable power banks. Okay, so we see something similar as portable power banks. As the units increase, total utility increases. We can again calculate marginal utility as the change in total utility. And in that last column, we're told that the price of a portable power bank is $3. And so we can again calculate marginal utility per dollar spent on portable power banks. Okay, great. So let's run through a little thought exercise here. If you were this consumer and these were your utilities and marginal utilities and all that, what would be the first thing that you would buy? What would get you the most satisfaction for your money? If you need to, pause the video and think about it for a second. But hopefully you came to the conclusion that the first digital app would give you the most satisfaction for your money. And that's because the marginal utility per dollar spent is 10, and that's the highest marginal utility per dollar. So the first thing you would buy if you were this consumer is that first digital app. Okay, so you buy that first digital app. And by the way, take note that this consumer's income or budget is $26. So, okay, they buy that first app. Maybe I'll keep track of this here. They buy that first app. They had $26. They buy that first app for $5, and now they have $21 left over. Okay, so they still have money to spend. So what's the next thing they're going to buy? Well, again, they're going to try to find the thing that gives them the most satisfaction for their money. And that turns out to be the second app. The second app gives them 9 utils per dollar. So that's still the highest bang for their buck. Okay, so they buy another app for $5. Let's see. That means they have $16 left over after that. Okay, so what's the next thing? What's the next item? They've got two apps. What's the next good that gives them the most satisfaction for their money? The next one would be the first portable power bank, 8.3 utils per dollar, as opposed to only 8 utils per dollar for the third digital app. So they're going to go ahead and buy the third thing they're going to buy is a portable power bank, which costs $3. Okay, so now they've got $13 left over. The next item would be the third app. That's the next thing that gives them the highest satisfaction per dollar. So that third app is $5. They have $8 left over. And as it turns out, the fourth app and the second portable power bank both give the same satisfaction per dollar. So it doesn't really matter which one they buy at this point. They could buy the fourth app or the second power bank. It doesn't really matter because they can actually afford both, right? So let's just say that they buy the fourth app for $5. They have $3 left over. And then they buy that last second portable power bank and they're out of money. Okay. So that's the nature with which a consumer theoretically makes their choice. Now, I should point out here, nobody does this. Nobody does this in real life when they're making a choice, right? So I will remind you that what we do in economics is we build models, right? So although when you go to the store and you decide what to buy when you're at the store, you're not doing this in your head. You're not making these calculations in your head. You act as if you are making these calculations, right? So that's the interesting thing. So nobody does this in real life, but people act as if they are doing this. That's when they make choices, they act as if this is what they are doing. And this has been tested experimentally, and this consumer choice theory is an incredibly strong model for consumer choice. So again, this is not what people are actually doing. We're not modeling how people think. We're modeling how people behave, and people behave as if they are actually doing this. Okay? So keep that in mind. All right, so here's an interesting real-life example of consumer optimum. So why a consumer optimum can include unlimited consumption in a pay-by-the-minute cafe. So there are these things called Zifferblatt cafes, which means clock face cafes in Russia and some other European countries where customers pay a total price equal to the number of minutes spent in the cafe multiplied by a fixed per minute fee. So basically, you go in and you're charged, say, 50 cents per minute, and that's how it works. So if you're in there for 10 minutes, you're charged $5. If you're in there for 20 minutes, you're charged $10, and so on. Now, when people enter these cafes, they get unlimited food and drink. So it's basically kind of like an all-you-can-eat buffet. So although these are unlimited, the customer's time as well as their income are limited, right? So consumers will devote time to consuming those items. What does that say? Consumers devote time to consuming those items to consumers devote time to consume. That must be a typo. Anyway, so hopefully you get the point here, right? Think about an all-you-can-eat buffet. This is kind of like the same thing. How is it that all-you-can-eat buffets don't go out of business and lose money? Well, it's because they charge enough money so that on average, each consumer doesn't eat them out of business, basically, right? They know that consumers behave as though they experience diminishing marginal utility, and so at some point they will stop eating, and the cost of the food to them is lower than what they charge to get into the place, right? So interesting real world example there. Okay, so here's the steps that I basically already went through. If you want to, you can pause the video and take a look at this and verify it for yourself. But in any case, those are the steps there that I already went through. All right, so what we just saw going through that exercise is that a consumer's money income should be allocated so that the last dollar spent on each good yields exactly the same amount of marginal utility per dollar, because this rule yields the largest possible total utility. So let's think about what that means. We saw in that last example, right, we saw in that last example that the marginal utility per dollar on the apps was 7.3, and so was the marginal utility per dollar spent on portable power banks, right? So that's basically what we're talking about, the marginal utility per dollar, right? The marginal utility of good A, let's say, per dollar spent on good A, which is the price of good A, should be exactly equal to the marginal utility of any other good, say good B, divided by its price, right? So let's think about why that should be true in a consumer optimum. Now, this is true for all types of goods, but we're gonna simplify it and just assume that there's only two goods. But if there were many goods, this should still be true across all goods. So equals MUC per dollar spent on C, etc. Right? So let's think about what it would mean if this wasn't true, right? So one alternative to this is that MUA, the marginal utility per dollar spent on A, is greater than the marginal utility per dollar spent on B. Now, if that's the case, well, we already saw this, right? It means that the consumer should buy more of good A and less of good B. This is exactly what we saw when we were going through the steps, getting to consumer optimum in that last exercise there that we went through. Okay, because it's basically saying A gives the consumer more satisfaction for their money than B does, if this is true. So they should consume more of A and less of B. That will help them get a higher total utility. Okay, so now as they consume more A, what happens to their marginal utility as they consume more A? Well, according to the law of diminishing marginal utility, as they consume more A, the marginal utility of A starts to go down, right? Now this goes down. As this goes down, what eventually happens? This is decreasing. Oh, and by the way, if they're consuming less of B at the same time, marginal utility of B is going up for the same reason, right? So this is going down, this is going up, this is bigger, this is smaller, but this is going down and this is going up. So what eventually happens? Well, at some point they become equal, right? And then the same would be true if we thought about the other inequality, if the marginal utility of B was greater than that of A. Same logic, right? They'd want to consume more B, and as they do, the marginal utility of B decreases, so the marginal utility per dollar decreases, and as they're consuming more B, they're consuming less A, and so the marginal utility per dollar goes up, and at some point they become equal. Okay, so this is why these things have to be equal if the consumer is going to reach an optimum. All right, so hopefully that makes sense and isn't too confusing for you. If you're having trouble understanding that, please feel free to email me, reach out to me, and I'll try to help you out. But this is basically what we get as a result of that logic, is that if the consumer is going to reach an optimum, then at that optimum, the marginal utility per dollar spent on every single good is equal across all goods. Otherwise, if that's not true, then they are not optimizing. They are not making the best choice. Oops. All right, so let's think of another example. Monitoring the provision of legal services to ensure the attainment of a consumer optimum. So there's an app called View a Bill and other similar apps that allow clients of a legal firm to engage in real-time monitoring of legal services as the law firm provides them. So I guess it's it's kind of like a way to check in on the law firm, making sure they're doing the work that you hired them to do. So clients can contact the firm to alter the quantity of hours of services to be consistent with the client's preferences. So basically, these apps are helping to assure that the marginal utility per dollar spent on the law firm services is equalized with the marginal utility per dollar spent on other things the client wishes to purchase. So there you go, a real world example of an app that actually helps consumers achieve this.